all these websites, right? The links are given in your notes already. You can go and scan the QR code and play around with it yourself. So here we have a parallelogram. You can adjust the size of the parallelogram. Okay, you can drag this point that indicates how you want to separate the parallelogram. So we drop a perpendicular line down. We end up with two parts. Okay, so depending on where you place this dot, you end up dividing it into two parts. So I like to put it at the edge that results in a triangle and a trapezium being formed. So as you continue to slide, you see that it will form a nice rectangle. So the area did not change. We are just rearranging the parallelogram into a rectangle. So we know the area of a rectangle being the base times the perpendicular height. So where did that come from? It came from the dimensions of this parallelogram. Changing the shape, the dimensions of the parallelogram will result in different triangles being formed, but the way you calculate the area will still be the same. You still get a rectangle. So what happens if we drag this to, let's say, this point? You still drop a line down and you still end up with the same rectangle area. Okay, so that is for our parallelogram. Now let's resume with our notes. Yesterday we stopped at this question, exercise 4, where we talk about the ratio of the area of triangle DFC to the area of ABCD 3:10. So find the ratio of the sides. Now in your notes, I want you to put a star beside this question. And we will see more of this, because this is another favorite topic, favorite concept that we like to test you on. Okay, we are going to mix ratio with area. Ratio of area. And here is the important tip that I have for you. All of these questions are, listen, this is the important tip. You miss it, you will have a hard time in future doing this type of question. The tip is to search for a common perpendicular height. I say one more time. The tip is to search, identify the common perpendicular height. Common means the same perpendicular height. Between what shapes? Well, we are in this case, we are talking about a triangle and a parallelogram. Apparently, based on the tip, the triangle and the parallelogram, they have a common perpendicular height. Once we can find it, our job will be much easier. So I've already drawn in blue. Yesterday, we said that we cannot assume that DF is the perpendicular height. Nowhere does it indicate that it is the perpendicular height. So we cannot assume. We have to draw another line ourselves, and we say we let that be the perpendicular height. We let it be. Now you should be thinking, if I don't even have that value, if I don't have that value, what use is it? Don't worry. Let's see what will happen with our ratio. Okay, so we let. Now we continue with the notes. Let the perpendicular height, or okay, let the common perpendicular height. That will be better. Let the common perpendicular height be h. Okay, that's our first line. If you didn't write that, then do you have an unknown in your working? If you don't have an unknown in the working, is your working made out of lines and lines of calculation without explanation? A triangle equal to? Where is the 3 from? Where do you get 3 from? We have to look at it whether it is easily understood. Okay, so here we have a common height. That tells us that our triangle has a corresponding base and the parallelogram has a corresponding base. Okay, can you identify the base of the triangle based on that perpendicular height? You see the base? Base will be FC. Using the same common perpendicular height, can you find the base of the parallelogram? Okay, what is the base of the parallelogram over here? Coach Chung, what do you think? What's the base of the parallelogram? This parallelogram has 4 sides. So based on that blue color perpendicular height, what will you choose as the base? BC, correct. Because the base has to be perpendicular to the perpendicular height, of course. So we have to use the base as BC. So now we are ready to write down the equation. Step 2, ratio. We're going to translate this to mathematics. Area of triangle to area of parallelogram. Write it as a fraction. Half times the base of the triangle. Base, we say that it is FC. Times H. I have just written down an expression for the area of triangle. Over. Now I'm going to write down the area for parallelogram. Guo identified that the base will be BC. And it has the same perpendicular height. Now we have written our ratio in a fraction form. We know how to do that. First fraction, first part of the ratio in the numerator, second part in the denominator. And this is equal to 3/10. It is given to us. It is given to us 3/10. At this point, you should be very happy because the strategy worked out very well. Remember, the strategy was to find the common height, common perpendicular height, which is H. Now look closely at your ratio, or look closely at your fraction. H over H. Cancel lah. Right? We can cancel. It doesn't matter what the value is. It is common. We are going to divide it away. I don't care what the value is. It wasn't given to us. It doesn't matter because it is the same. That was what we set out to do. And now our fraction on the left-hand side is half FC over BC. Our objective is to find FC to BC, which means if I can write this, if I can obtain an expression for FC, if I can obtain FC over BC equals to something over something, I got it done already. I know the answer already. So right now, instead of FC over BC, I've got this annoying half over here. How do I get rid of that half? What should I, why is it 3/10? It is given a question. What should I do to both sides to get rid of that annoying half over there? Times what? Times 2, yes. You multiply 2 to half, it becomes 1. Multiplying by 1 is as good as getting rid of it. It's as good as the half not existing at all. So multiplying by 2 results in FC over BC equals to 6/10. Okay, now of course 6/10 we have to simplify to become 3/5. Now that I have FC over BC, I can write down the ratio of FC to BC already. Final answer, FC to BC equals to 3:5. Get how this is done? So this concept, very important. We will see more of it in the subsequent questions. Must be able to do this. So as you're writing your own notes, right? Because I noticed that I didn't write it down over here. The strategy, find common height. Okay? Okay, let's try the next question. Exercise 5. ABCD parallelogram. Make sure you understand the question. AB 6 cm, okay? Area of triangle ADE is refers to equal sign. I can't remember. The word is, you can write down your notes. It just means equal sign, okay? The area of triangle equals to 3/4. I am now translating the English to mathematics already. 3/4 of. The word of is times. So the area of triangle is 3/4 times area of parallelogram. Understand what's happening? So let me fill in the blanks. Area triangle equals 3/4 times area parallelogram. Okay. Then after they say, find the length of BE. The good thing about algebra is that once you are able to translate the question to mathematics, it saves some of your brain power. Because once you're familiar with the rules of algebra, you don't have to keep thinking about working backwards, this times this, that times that equals to whatever. Because the algebra will settle it for you. Okay, so now area of triangle and parallelogram. Can you find a common perpendicular height? Because that was the strategy, right? Common perpendicular height. Can you find it? If you can, please draw it on your notes now. Draw your common perpendicular height for the triangle and the parallelogram. Once you have done that, identify where your base is. The base for a triangle is quite obvious. What about for the parallelogram? In the first place, do they have the same base? Okay, I believe you are done. I'm now going to draw my common perpendicular height. You see whether yours is the same as mine. This is my common perpendicular height. Is it the same as yours? Not the same, huh? Did you draw it elsewhere? But do we all have the same distance? Is my distance the same as yours? Yes or no? The answer is yes. Although I chose to draw it at a weird location, but I just want you to realize that even if I drew it over there, it is still the same perpendicular height. Now, most of you would have, if not all, would have drawn it this way, right? Red color. It's the same. You see, the blue line and the red color dotted line, they are the same distance. So sometimes it will be necessary for you to draw it elsewhere. Perhaps it is over here. These are all possible. Your requirement is to know that they are all the same. Okay, so let's use what is more common. So if this is the base, where this is the common height, where is the base of the triangle? Obvious, AE. And where is the base of the parallelogram? It will be AB. Now we have this information already. I can now write down an expression. I didn't say find the area of a triangle. I didn't say I can find area of a triangle, but I can write down an expression for area of triangle. Then I just continue, equal to 3/4 times expression for area of parallelogram, and I see what happens from there. So let's start. Area of triangle, half times base. The base for the triangle with that common perpendicular height is AE. And I multiply by the perpendicular, I forgot to write. Let the common perpendicular height, blah, blah, blah. Okay, so good practice. Let common perpendicular height be H. So you label over here H. Let the common perpendicular height be H. So area of triangle, half times AE times H equals to A 3/4 times area of parallelogram. Area of parallelogram has an expression, formula, base times perpendicular height. So this will be AB times H. And the power of algebra comes back. You see that unknown H? Wow, very uncomfortable. In primary school, you'll be very uncomfortable. I don't know what that is. How? But in secondary school, I tell you, hey, both sides multiply by H. How about you just divide both sides by H? Just divide both sides by H. So here, divide by H, divide by H. We end up with half AE equals 3/4 AB. No more H. Okay. Then what else did they say? Find the length of BE. Oh wait, hey look, they told you that AB is 6 cm. What do you think you should do with it at this point? Might as well substitute, right? Substitute, yes. We know that AB is 6. So half AE will be 3/4 of 6, which will give us 9/2. Okay. Easier. That you're saying you don't want to do with fractions, lah. Okay, can. Yeah, it's the same actually. Okay, so the next step will be to get rid of this annoying half, which is to multiply by 2. AE will now be 9 cm. But is that what the question wants? No. Yeah, they wanted BE only, this tiny portion. But I instead found AE. AE is 9 cm. Okay, so can you find BE by yourself? 9 minus 6, and we get 3 cm. Okay. Another method. Do you want to share? Can you show it to me?
Instead of trying to find that, I find the percentage of this.
Percentage. Okay. How do you find the percentage of this to this?
Because they say that AD
Area.
the area is ADE. So then I realized that if you make this a square or something, a rectangle, then this is 3/4 of this. So then after that, I realized that this you can shift, because these two are the triangles, right? Then you can shift it longer for B to be here instead. So this is the length of the bottom of the triangle, and then this is BC.
Okay.
Then if you check, then after you realize that this is actually one and a half of this, which is 1.
Okay.
So when you know this is 1 and a half of this, then just divide by 2. So you get
Okay. Is that reflected over here?
I wrote length of AB by the length of BC percentage. So this is the percentage.
Okay. First, I don't see any percentage. Next, I don't understand why it's like this. When you explain to me, I know. But when I see this, I don't understand. Makes sense, right? Okay, so learn the different ways. And I can see you're enjoying that. Okay, next one. Exercise 6. Oops, I gave you the hint. Okay, now we got ABC. ABCD is the parallelogram. BC 12 cm. Triangle ABE area 1B that of parallelogram. Find the line of B. What is the strategy? Find what? Common perpendicular height. Okay, now your job. Find common perpendicular height for the triangle ABE and parallelogram ABCD. Where is the common perpendicular height? You can rotate your iPad such that you consider all 4 sides, which is suitable as a base that will result in a common perpendicular height. Okay, try it by yourself. Okay. Very tempting to say that this is the perpendicular height. Okay, let's look at this line in red. Is this a perpendicular height? Oh, listen to my words. Is this a perpendicular height? Yes, it is a perpendicular height for what? For which shape? For the parallelogram. However, is it also a perpendicular height for the triangle? No, it is not. It's got nothing to do with the triangle. So is this red colored dotted line the common perpendicular height? No, it is not. So this is unfortunately, in this case, useless. Okay. Now, if that is not the perpendicular height that we are looking for, then where else do we have a perpendicular height for the parallelogram? So again, rotate your iPad, rotate your notes, extend one side, and say that, yeah, I can drop a perpendicular line down. Okay, now I've got a perpendicular height. Instead of extending, we can also do it this way. On this side, Isn't it the same? Right? Both the blue and the red color dotted lines. Are they both alternative perpendicular heights for the parallelogram? They are the same length. It's just that the base this time will be BC. And now you think about it. Since the previous perpendicular height was not a common perpendicular height, let's look closely. Is this also the perpendicular height for the triangle? Now we conclude, yes, it is. It is the perpendicular height for the triangle. That is what we need. Whether you use the blue or the red, they are the same length. Okay, I think it is easier for us to refer to the red color perpendicular height. So this is our second instance. Is it a second? No, this is the third instance. The third example where we deal with common perpendicular height to solve a question. Reason we make you do it over and over again is because it is an important concept. We need you to be able to apply it during our tests and examinations. If by now you still do not know the significance of this common perpendicular height, you have unfortunately wasted like 25 minutes of your time in class. This 25 minutes, if you want to catch up by yourself at home, you need to spend more than 25 minutes. Are you willing to put in that effort at home? More time to achieve the same outcome. If you're not willing to do so at home, if you have better things to do at home, then your decision should be to follow closely in class so that you don't lose out and you don't regret. All right. So here we have our common perpendicular height ready. Let us now write down let's indicate on the diagram where our bases are. The first base, we can deal with the triangle. This will be the base of the triangle with that red color perpendicular height. And this will be our base of the parallelogram with that common perpendicular height. And now we form equations. What did the question say? Okay, area of triangle is. Where is that area? What is that area of triangle? ABE. Area of triangle formula, primary school. Half times base. We have decided to use BE as the base. Why did we choose that? Because we have a common perpendicular height. If you chose AB as your base, very tempting to choose AB as your base because it's horizontal, right? By default, in primary school, your maths for triangles, the base, even as the English word suggests, base is at the bottom. But it doesn't work over here. You need to rotate your paper. If you chose AB as your base, you don't have a common perpendicular height. Doesn't help you. So half times BE times your common perpendicular height, which I forgot to define again. Let common perpendicular height be H. Okay, so half BEH, that is my area of triangle, as mentioned in the question. So this is the translation, area of ABE. The word is just means equals. Is 1/5 equals to 1 over 5. 1 over 5. Okay, all this in green. The area of triangle is 1 over 5. That of the parallelogram. Use another color. Let's use purple. Area of parallelogram. So I'm going to put the area of the parallelogram over here. That will be the base, BC. Multiplied by the common height. Okay. You see the translation from English to mathematics. That is what I want to see. I want to see a common height, HH, so that I can cancel it. If you use different heights, if you didn't use common height, you're going to end up with 2 more unknowns, H1, H2. Makes things worse for you. Now, with this, we can cancel. When I say cancel, I mean divide by the same number on both sides. I'm going to divide by h on both sides, resulting in half BE equals 1/5 BC. Okay, and oh, how convenient. Question already told me that BC is 12. Substitute it in. So half BE is 1/5 of 12. They want us to find BE. So we just need to get rid of this half in front, the coefficient, by multiplying by 2. So BE equals to 1/5 times 12 times 2, resulting in 4.8 cm. Can this be done without algebra? Can this be done without considering perpendicular heights? Maybe you still, okay, can this be done without algebra? Can. If you want to know, find Jovan. He will bring you through his theory about cutting this and that, moving here and there, and then he just has a few lines, provided you understand what he's doing, provided the teacher will understand your work. Okay, so it can be done. But the easiest method is to use algebra. Once you are familiar with algebra, it helps you greatly in reducing the mental load that you have. Okay, next one. You can try it yourself. Moving on. Can. Moving on to rhombus. Okay. Have you all learned rhombus in primary school? Heard of it, huh? Okay, so just recap. What is a rhombus? Four sides equal in length, opposite side parallel, opposite angles equal, diagonals bisect each other. This will be something new compared to your primary school, but it is still part of the parallelogram property, right? For parallelogram, the diagonals also bisect. Another point, diagonals are perpendicular to each other. So I want you in your notes, whether it is your iPad or hard copy notes, put the 90-degree symbol, the right angle symbol in all of them to remind yourself, this is a property of rhombus. Okay, with that, you can also indicate dashes like this to remind you that they are of the same length. So use another color. One dash, two dash to indicate which are the same. Okay, so for rhombus, right, the four sides are equal. Will the diagonals have the same length? You know, rhombus, four sides equal, right? Will the diagonals have the same length? Does it look like same length to you? Does it look like it? Diagonals. Look closely. Imagine if you can change the shape of the rhombus. You hold on to A and C, you compress them together. Do you still end up as a rhombus? It is still a rhombus when you compress them because all four sides still have the same length. But what about the diagonals? It's going to change. So another common mistake is that thinking that the diagonals have the same length. No, they don't. Take a ruler and measure. AC is shorter than DV. Take a ruler and measure. Okay, so first question, is a rhombus or a parallelogram? What do you think? Is it a parallelogram? Yes, you think so? Exactly. Yes, it is. Why? It satisfies all properties of a parallelogram. Is a parallelogram a rhombus? So this will be no. Is a parallelogram a rhombus? Actually, not necessarily. Okay. Most parallelograms are not rhombuses. Unless the sides have the same length. So I explain the reason. all four sides of a parallelogram do not have to be same in length. All four sides don't need to be the same one. Only need two opposite sides to be the same in length for it to be a parallelogram. Okay, so you can just word it yourself. Now the next interesting one would be the area of a rhombus. The notes already told you that the area is half times diagonal 1 times diagonal 2. It is easy for us to apply this formula. Given AC 16, AC 16, DB 10. What is the area? Follow the formula. Half 16, 10. Answer 80 square centimeters. Simple. No? Simple? Do you think you can do rhombus 2, 3, and the last one by yourself? Okay, do it now. 1 minute. I think 1 minute is enough. Okay, rhombus 2, what is the area? What is the area? Half and 48. Okay, next one. Half, 4, and 16. 32 square centimeters. Final one. Area of AB lah. Okay. Do you like this portion of the lesson of area of rhombus? Do you like it? You like it? AB over 2, yeah, it's the same. Aren't you curious about why is it half times diagonal? I'm disappointed. No. After I teach so much, I'm trying to get you to be interested in the reason. Now you tell me you are happy with just a formula thrown to you. Yeah, I know exam they won't ask you why is it like that, but isn't there a part of you that wants to know? I don't care. I still want to teach you. Okay, let's start with this. Oh, you know what? Let's use this. Half AB. Okay, look. Boss, I firmly believe it is important to understand why lah, so that it doesn't become just pure memory work. Look at this diagram for the last rhombus. We can split it up into 4 triangles, right? In fact, we could have just split it into 2 triangles. Let's consider these 2 triangles in green. What is the area for the top triangle? Area half for the top triangle, the top green triangle. Half times the base, right? What is the base? What is the base? Base is B. Half times base times height. What is the height? Is it A? Are you sure it's A? Half A. Half A. So what is the area? 1/4 of AB. That is the area on top, right? Can you visualize? Can you imagine what's going to happen already? Area of triangle at the bottom. Area of triangle at the bottom is the same area of the triangle on top, isn't it? They are the same triangle. So then the area must be double of your 1/4 AD. So the total would be 2 times of 1/4 AB, which is half AB. Okay, this is why we have that as the formula. How is it that we can use this? Sorry? cm square. Did they say that this is in cm? No, they didn't say it's in cm. Wait. But Glenn has a point. We should write square units. Oh, so yeah, square units. If we don't know the units, so the reason we have this formula is because the property says it is 90 degrees. It is perpendicular. Diagonals are perpendicular. That is why we can use this. If this is not a property of the rhombus, then we cannot use it already. Okay, so textbook questions. This will be due when 14. Tomorrow lah. 15. Yes, we have lesson tomorrow. So due on 14. Okay, let's carry on with the next set of notes. Trapezium. Okay, now for trapezium, how is it different from our parallelogram, from our rhombus? Is that it only has one pair of parallel sides. Fill in the blanks, parallel. BD parallel AC. Chapter 12, part 3 already. Can you imagine what happens when we only have one pair of parallel sides, but they are the same length? What's going to happen? Imagine, what if parallel, one pair parallel and same length? What's going to happen? What shape will you get? You see, in the definition, right? Oh no, it's a wrong word. This should be trapezium. Okay, please change it. Okay, so our definition says that the trapezium only has one pair of parallel sides and they are unequal. So I want you to imagine what happens if you extend BD to match the distance of AC. What would the resulting figure look like? What we get? Trapezium. We still get a trapezium. If it is the same length, yeah, you get a parallelogram, isn't it? Extend it, and take a look yourself. Extend until it's the same distance and join. Yeah, you get a parallelogram already. Okay, that is why we say a trapezium must have unequal length for the parallel sides. The moment the parallel length are equal, we're going to end up with a parallelogram already. Oh, by the way, is a rectangle a parallelogram? Is a rectangle a parallelogram? Technically, yes. Is there any property of a parallelogram that a rectangle doesn't fit? Really? Rectangle doesn't have two parallel sides? No, I'm just talking about parallelogram. Sorry, I'm not talking about trapezium. I suddenly talk about parallelogram and rectangle. So it's a rectangle or parallelogram? Yes. It fulfills all the properties. Okay, back to a trapezium. AB is not parallel to DC. Okay, next one. Angle A plus angle B. What will it become? 180 degrees. What is the reason? Interior, very good. Angles, is that the end? Parallel lines, good. So you will be tested on angles for your next topic, for next WA. Your next weighted assessment is in week 6. We are currently in week 3. Okay, next. What about the other two angles? Angle D and angle C. What will it give us? Same, 180 degrees. Interior angles, parallel lines. Okay? So keep on revising so that you have an easier time. Let's move on to the GeoGebra. Let's see. We've got area of a trapezium this time. Okay, this is my trapezium. I'm going to adjust the dimension of the trapezium. Okay, I can do so. Okay, so this is a trapezium. The way to visualize the area of a trapezium. Everything okay over there? Okay, any issues? Okay, it is by forming. Okay, watch. What shape do you see now? Parallelogram. Okay, reverse it. What shape is this? Trapezium. What I have done is to duplicate the trapezium and I bring it to the other side, which results in a parallelogram. Does this give you a clue on how to calculate area of a trapezium? Okay, now what if our trapezium has a different shape? Let's make it look like, how about like this? No, not a parallelogram, still different in length. Okay, let me exaggerate a bit more. Okay, not a parallelogram, different length. Okay, I'm going to duplicate it and I still get a parallelogram. Let's make it like this. Okay, like this, let's see what happens. Still a parallelogram. Okay. Have you learned how to calculate area of a parallelogram? Yes, you have. Now, are you able to calculate the area of this parallelogram? Yes or no? You are expected. You are expected to be able to calculate the area of this parallelogram. But what information do you need? What information do you need to calculate this area? Base, right? With your what else? Perpendicular height. Alternatively, base and corresponding perpendicular height. Now we're going to focus on this base first. Base and corresponding perpendicular height from a trapezium. Okay, listen carefully. Listen. We are going to talk about finding the area of the trapezium very soon. We say that I can find the area of this parallelogram if I know the base and the perpendicular height. So assuming you got the area already of the parallelogram, what are you going to do with it to find area of trapezium? Okay, one more time. The question is, assuming you have the area of this parallelogram, what are you going to do with that value to find the area of a trapezium? Correct, we have to divide by 2. Okay, so now our objective is finding the area of this parallelogram. But the original question doesn't have a parallelogram. Original question is a trapezium. So if I give you the perpendicular height of this trapezium, will it correspond to the perpendicular height of the parallelogram? Is this perpendicular height the same perpendicular height as this parallelogram? Yes. So I must have that information. I need the perpendicular height of this trapezium. What else do I need? I needed the base of that parallelogram, right? Can you visualize the base of the parallelogram again? Is this the base of the parallelogram? No, it's not. It's too short. Is this the base of the parallelogram? No, it's not. It's too short. Let's take a look at it again. What is the base of the parallelogram? It is made of 2 parts. The longer side of the parallel line plus the shorter side of the parallel line. Same distance. In summary, my area of a trapezium will be half of the area of a parallelogram. And the area of the parallelogram is given by the base, which is long side plus short side, put it over here, multiplied by perpendicular height. Get it? That is the derivation of the area of a if you do not want to go through this mental exercise, where's my stylus? Yeah, okay. So, if you do not want to go through that mental exercise, you just want the formula, like half times diagonal. Fine, go ahead. We will end up with the formula. Okay, give me a moment. This is the formula that you need to know. Half times sum of parallel sides times perpendicular height. You need to know all this. Okay, so you can fill in the blanks. What shape is formed in diagram 2, parallelogram. Your teacher is very lazy, too lazy to spell parallelogram, but you need to spell it. Okay, you need to spell P-A-R-A-L-L-E-L-O-G-R-A-M. Okay, area of the shape form will be A plus B times H. Okay, the area of the parallelogram, the blue and the yellow piece joined together. So the area of one of it must be half A plus B times H. Half of A plus B times H. So when we say it, when we remember the formula, it goes like this. Half times sum of parallel sides times perpendicular height. And we can try exercise 1A. Very fun, very simple. Okay? Identify parallel sides. Quite clearly, if it is a trapezium, it must be KH and FG. Add them up, multiply by perpendicular height. In this case, given to us, there's a, okay, this particular one has a special name. It is called a right angle trapezium. What do you want to find for what? Are you talking about part B? I got 2 trapezium. No, I don't see 2 trapezium together. I only see 1 trapezium. Where times 2? Where is the times 2? So you don't have to make it a parallelogram. You just remember it as half area of parallelogram. If you times 2, then what do you call it? You mean you want to say area? No, you want to write 2 times area. You show it to me later. Okay, so the rest of you try question B and C by yourself now. The answers are given to you. Do it quickly. Yes.